Well, well, what has the cat dragged in today? It's a tutorial on Unity's input system. Note, I said input system, not input manager. Unity has two input methods currently available. The default one, which is the one that Unity's been using since the 3.0 era, which is the input manager, and the new-ish system, the input system, which is far more flexible and has quite a few cool little features to it. However, there are some gotchas. As always, before we dig into this, take note of the version. I am using Unity 2021.2.7. Everything that I am going over should be the same for all 2021.2 versions. First of all, we need to get the input system instead of the input manager. To do this, we're going to have to go into the package manager, make sure you switch it over to the Unity registry, and then navigate down through it to find the input system and install it. When you install the input system, it is going to give you a dialog box prompting you if you want to enable the back end. You want to click OK to this because otherwise the input system's not going to work. Clicking OK will trigger an editor restart. So if you are wanting to follow along with me, you should probably pause the video here and make sure that you have the input system installed and ready to go. For this little demo, I am working off of a new clean scene here. And we're just going to do a basic cube rotation. So I'm going to drop in a cube. I'm going to make sure this cube is at the center of the world, so I will reset its transform. And because I want to be able to easily tell what is the front of the cube, it's a personal hang-up. I have trouble correctly visually processing a rotating cube if there's no indication of where the front of the cube is. So I am going to drop on a sphere as a child object, crank that scale down, and drag it forward a bit. So that way I've got a little visual indication of where the front face of the cube is. I'm going to position my editor camera so that I am above and behind my cube. And then I'm going to grab my main camera and align to view. Control-Shift-F, or you can go through the game object menu. And that's all the scene setup that we need to really worry about. Now, how do we use the input system? The input system comprises of two main categories of things. You have action mappings and you have actions. In order to use the editor to create these, we are going to want to create an asset. So I'm going to come down here. I've got just in a demo folder for sake of this recording. I'm going to right click, create, or we could go through assets, create, and then input actions. If you do not see input actions down here, then that means that was not imported correctly. I'm going to call this demo actions. Again, name is irrelevant for the assets. And then I'm going to double click on it, or I can also click on the Edit Asset button over here. This is going to open the Action Editor window. When you create an action asset like this through the right-click Assets Creation menu, you are going to have no mappings and no actions. I will, at the end of the video, show an alternate method that will give you some basic WASD controls. Maps, in general, are collections of actions. You can use mappings for a variety of things. You could have a set of mappings for on-foot movement. You could have a set of mappings for flight, a set of mappings for vehicle, so on and so forth. Or you could distribute the mappings based on input method. For this demonstration, since we're just concerned about the bare bone basics, we are just going to create one action map. So I'm going to click on the plus sign right here. And I am going to call this cube control. Because, well, that's what I'm going to be doing with this mapping. It's going to be controlling a cube. It is automatically going to populate an action, which we can get rid of by just hitting the delete key. In order to create our own actions, we can click on the plus sign right here, and it will create a new action for us. There's nothing special about the default action that was created. We could have just as easily used that. I wanted to show how to create your own action here. This action I am going to call rotate. As again, that is what the action is going to be. We are going to rotate the cube with it. Now, an action can be of three different types. It can be a value, which you then have a selection of values that the action can generate. You can have it be a button, so you're just checking to see whether or not the button has been pressed or not. And you can have a pass-through, which is where you want to pass the action along to something else. This is primarily used for UI. What we are going to want for this particular example is we're going to want a value. And then the control type that we want is a vector 2. This default binding that it created for us is not going to work, so I do need to delete this. And then I can click on this plus sign right here to add a binding, and I'm going to want to add a composite binding. Now, this is, strictly speaking, a bit more complicated than it has to be. But it's important to know how to do the 2D composite or even the 3D composite bindings, because these are very common things to use. You are going to want to use a composite binding at some point. So since this is a 2D vector, I have up, down, left, right. I am going to ignore the up, down, which is going to be bound to the Y, and instead I'm just going to do keybinds for left and right. To set the actual keybind, I'm going to need to come to this path here. And you got lots of options. Lots and lots of options. Honestly, the easiest way for most scenarios is to click on Listen and then start doing input. It does not work, by the way, trying to listen for the mouse input, because I'm clicking with the mouse. You'll just have to trust me with this. You know, it can pick up on the right mouse button, but it can't pick up on the left mouse button, because obviously if I left click it, yeah. So it is a little bit twitchy with the mouse. For anything else, it works. Listen works great. So if I want to bind this to A and D, I can press A, and it's like, oh, okay, well, are you wanting the A key, or are you wanting to listen for any key? Well, I want the A key. Thank you very much. And then for the right binding, I can also do the key, so I can go through keyboard, by character map to key, B. And then I just realized that I entered in the B key instead of the D key, and yeah, let's actually get that working correct there. Okay, So this is the bare level basics of binding commands to an action. So again, we have an action map, our cube control, we have our action, rotate, and we have our binds of A and D, which are going to be mapped to this 2D vector. Next up, we need to use this. Now, I want to point out right now, I am deliberately committing a mistake right here. It's a very easy mistake to make, which is why I'm doing it, because I want to show what the result is. Let's continue. So I now have some input actions created. I have a mapping and I have actions. I want to get this onto my cube. Well, to do that, I'm going to have my cube selected, and I am going to click on Add Component. And I'm going to filter it by typing in input in the search bar here, and I am going to want the player input component. The player input component is going to want me to assign it an actions asset. I can either use the picker, or I can drag my actions asset into that box. We can set a default map if we want. And then more importantly, we can set our behavior. You almost never want to use send messages. This is almost always a bad idea. Send message is phenomenally bad when it comes to performance, especially on mobile devices. Instead, what we want to use is we want to use invoke C# events. There are certainly reasons, good and bad, for using all of these, including send messages. But for the purposes of this demonstration, I'm going to use the C# events because as a more traditional C# programmer, honestly, that's how my mind works a bit better. And it allows me to show off a couple additional features of the input system. All right, so we're going to invoke C# events, but how are we going to know what those events are? We have a couple of different ways of getting there. Probably the simplest way, especially if you're not a hardcore programmer, would be to generate a helper utility file and use that to hook into the events. We can do that by looking at our actions asset in the inspector, and one of our options here is to generate C# class. Now, you are going to most likely want to leave all of these as defaults. Class file, class name, namespace. The only one of these that you should really mess with, unless you know what you're doing, is the class file. Where do you want this file to be stored? In this case, I am perfectly fine with it being stored in the demo folder. That's why I have the demo folder. So I'm just going to leave everything at default. Again, I want to stress, do not mess with the class name or the class namespace unless you are a programmer and you know what you're doing with those two options. I am going to hit apply, and it is going to generate, honestly, a pretty crazy looking class. Do not modify this. This is a generated file. We want to leave it alone. In order to use this, we have to write our own script. So I am going to select the cube. I'm going to add a component. And I am going to add in a cube controller, which of course this doesn't exist. So I am going to select new script, and I'm going to click on create and add. and then promptly jump into my root assets folder and grab my cube controller file and toss it into my demo folder because I like to keep things nice, neat, and orderly. My wife would call shenanigans on that statement. My Office, yeah. My code files, I like being neat. Office is an entirely separate thing. All right, let's take a look at our cube controller. Yes, I want you to reload. Now, for the sake of the video, I am going to bump up my font size here a little bit. Now, something we're going to be doing a lot of is, well, obviously interacting with the input system, right? So I'm going to put in a using statement here. Using Unity engine dot input system. It is not mandatory to have that using statement in there. It just makes it for a little bit less typing. Now, there are a few things that we need to set up here as class level variables. Again, a reminder. Scope in C# is the nearest matching set of curly braces. So if I want a variable to be visible throughout the entire class, I need to define it outside of any methods that I have. One thing I'm going to need is a reference to that utility file that was generated for me. As a reminder, I have called this demo actions. So I will put in the reference to demo actions, and I'm just going to call this actions. I do not need to make this public because I will be instantiating this inside of this class file. I am also going to want to have some number to tweak how fast the cube is rotating. So I shall do a public float rotate speed, which I shall set to a default value of 180 degrees per second. Or at least that is my intent. Remember, we never want to do things locked to the frame rate because that's bad programming and will get you into trouble. I'm going to use time.delta time to scale this, so this represents degrees per second. I am also going to need a vector2 to store the results from reading from the actions. This does not need to be public, so I shall simply say vector2 rotate direction, assuming I can remember how to spell direction. And that is all the setup that we need for this class. Now, there is a temptation to put a lot of our initialization here in start, but that is a bad idea. Let me type in what it's supposed to be, and then I'll explain why. In on enable, I am going to want to hook into some events. And then on disable, I'm going to want to unhook into those events. So on enable, I am going to check to see, check. That means I need to use the word if. There we go. If actions is equal to null, then, come on, autocomplete, thank you. Actions equals new demo actions. This utility file is just a regular old class, not like a component or anything, so we use the new keyword here. Then I need to hook into events. And remember that mistake that I said that I was making? Here's where it's going to happen. What I should be able to do is type in actions dot and then the name of my mapping. I don't see cube control anywhere on here. But it's supposed to be here. So why isn't it here? All right, well, let's hop back to Unity real quick. The reason being, notice this little asterisk here. Unity is very consistent with this in that an asterisk by something indicates unsaved changes. By default, this asset is not auto-saved on each individual change. And I would honestly recommend that you not turn that on, especially if you're allowing it to generate the code file. Instead, you just simply have to remember to click on this Save Asset button when you are done modifying your actions. This isn't a big deal because you're generally not going to be constantly modifying your actions. Once you're done creating your actions, you're pretty much going to be done. Now that I have saved it and it's regenerated the code file, I can go back to Visual Studio. Aha! There we go. Cube control. So I'm going to do actions.cubeControl. Now I want my action, which is rotate, dot. Now I have to hook into an event. So I can use a little lightning bolt to filter. I've got 3 events here. These are only called once. These are not continuous events. So in other words, when I first press down the keybind, or I first initiate the action is about to be done, you will get a started event. Once the action has been done, you will get a performed event. And then once you stop doing the action, in this case I release either the A or the D key, then the action is canceled. We're going to want both performed and canceled. In this particular scenario, performed or started, either or works, but we're going to go with performed and canceled. When you're linking into an event list, you use plus equals, and then you have to provide it with a method name. Now, in this particular case, I allowed autocomplete to autofill in the method for me. Actually, let me pull back on that. Let me delete that out and do that one more time. In Visual Studio, assuming everything is configured correctly, it's going, when you go to add into an event, it's going to give you this little prompt. Do you want to auto insert this? So if I press tab to insert, it's going to create the name, which I can now rename it if I want. Which I am actually, because I prefer camel case like that. And then I can hit apply or hit enter, and that will create the method that I need for me. I am also going to need a canceled. Same thing. Actions, or the instance of my utility code, dot the name of my mapping, dot the name of my action, dot the event that I am wanting to monitor, which in this case is canceled, plus equals, because I'm registering something to the event, and then tab to autofill in because I am lazy, and then rename it because I'm persnickety about my naming conventions. Then I'm going to copy these 2 lines, and I'm going to paste them down into on disable, and I'm going to change them from a plus equals to a minus equals to unregister the events. One last thing that we need to do in terms of setup here, or in terms of just getting everything linked up and actually ready to register, is I have to enable. Now we can enable all of the actions. We can enable a specific mapping, or we can enable a specific action. It gives us a lot of flexibility here. In this particular scenario, I am just going to enable all mappings. Oops, there does not need to be a 0 there. So all mappings are enabled, the one that I have, and all actions are enabled. Likewise, on disable, I am going to want to do actions.disable to ensure that once this game object is disabled, it's no longer trying to register actions. Okay, why do we need to do it this specific way, and why do we want to avoid start? This gets into the life cycle of events. So here is the Unity documentation on order of execution for event functions. And we can see here the order: awake, then on enable, then reset, then start. And start is only ever called once for a given script. There's lots of good things that you can do in start, but enabling the actions is not one of them. And here's why. Oh, and we scroll further down. When a game object is being destroyed, on application quit gets called first, then on disable is called, then on destroy. Okay, so why does this matter so much? Well, let's assume that you have this utility code on an object that has permanence across multiple scenes. And different scenes are going to be responsible for registering and unregistering their methods. You're going to want to register and unregister those events to ensure that you don't have just an endless registration of events. In this specific scenario, this is pointless. Unregistering the events in this specific example is pointless. There is no need to do it. However, it is a very dangerous habit to be in, to get used to registering events and not unregistering them. This will get you in trouble at some point. So, therefore, it's best to do good programming practice, and if we are going to register an event, we are going to unregister it. And again, since on enable is called before on start, and on start is only ever called once, this is where I want to do all of the enabling and hookups. All right. Let's actually rotate the gosh darn cube, because we've been at this for almost a half hour and our cube still isn't rotating. When you get an event from an action, it is going to pass in this callback context thing, which by default is going to be called obj. There's a couple of different ways that you can process this. We're just going to read the value off of it and get the x value out of our vector 2. So I am going to say rotate direction dot x is going to be equal to obj.readValue. Now we're going to want to use the angle brackets. Just like when we use get component angle bracket physics, here read value could be anything in that list that we saw. It could be an int, a float, a string, vector 2, vector 3, we don't know. So we use the angle brackets to tell Unity exactly what data type that we want. I want this as a vector 2. It's a method, so of course we need to have our open and close parens. And then I'm just going to directly access the .x property. Not going to do anything fancy with this. Now when I cancel this, I don't actually need to read object. Oh, well, no, not detail. What on earth am I typing? I don't need to read the callback context. I just need to set X back to 0. It's like, you're done. You're not rotating in any direction. And then an update, just going to use bog standard rotate code. So I'm going to say lowercase t transform dot capital R rotate. I am rotating around vector 3 dot up, and my angle is going to be my rotate speed scaled by time dot delta time multiplied by my direction. Easy peasy. Make sure my code is saved. Bring up Unity. Hit the run button. And nothing happens. That was an unintentional error, but it's a good one to demonstrate. We always have to remember to attach our code, right? I did not attach my cube controller code to the cube, so, shock and horror, it didn't rotate. So we shall fix that error. Drag it on. Oops, apparently I do have that added on multiple times. Hold on. Okay, I skipped over a step, so I'm going to pause my recording real quick so that I make sure I understand the error before continuing on. And through the magic of pausing the video, I'm back instantly. Okay, so that was an easy error to figure out. And this is why I do one-take recordings, because these are errors that you yourself could potentially make. Notice I put in my rotate canceled method, actually reading the value, and in my rotate performed, I'm setting my X to 0. That is precisely reverse of what it should be. So in rotate performed, I should read the value, and in rotate canceled, I should set it to 0. Pay attention when you're writing your code, especially when you're doing auto-generation, and make sure that you're in the right auto-generated piece of code when you're typing. Now hop back over to Unity. There we go. And now it is rotating. So I can rotate my little cube left and right. Hooray, another noises of excitement. Some other potential common errors that you can run into. You could forget to enable the action or the mapping or the action itself. So if I take out this enable line, even though I have everything else set up correctly, and now nothing happens. You'll just have to take my word for it that I am, in fact, pressing my A and D keys right now. Another potential error is making a change but not saving it. Oops, nope, that is not the file I meant to double click on. So let me take that comment off. So let's say I was tweaking around and I decided to add arrow keys on. It's a fairly simple thing to do. So what I'm going to do, since I don't need up and down, I'm going to hijack these. I will set down to right, and I will set up the composite part to left, and then I'll map these to the arrow keys. Okay, so path, listen, left arrow key, there we go. That's what I want. And coming over here to the right, path, listen, hit the right arrow key, done. Phenomenal, great, okay. Hit the run button. A and D, rotate. Left and right arrows do nothing. Again, you need to save the asset. That is a very common error to encounter of making a change or a tweak to your actions and your bindings and forgetting to click the Save Asset button. And now, A and D, left and right arrows. And that is the bare bones basics of the input system. Super fast recap. You use the package manager to find the input system, add it in, click OK on the prompt that will come up to restart the editor to enable the back end. The input system runs off of mappings, actions. So you create an asset. Once you have that input action asset created, you can double click on it to open up the input action editor. You can create as many mappings as you want. Each mapping will have its own set of actions. Each action will have one or more bindings that will determine when and how that action fires off. When you are done modifying your input action asset, you must remember to save it or click autosave. Autosave is not recommended if you will use utility code generation. If you plan on using the event system, it is advised that you create a helper class. If you look at your input actions asset in the inspector, you will have the generate C# class checkbox. Check that, hit apply, and it will generate a helper class. Unless you are a programmer and you know precisely what you are doing, do not modify the default values except for maybe the location. In order to use this code, you must have, and I keep clicking on the wrong thing, you must have your own separate code file. You must create an instance of that helper code. So here I am checking to see if things are null, and I'm creating an instance of the helper code. You're going to want to do this check and all of your enable calls and adding to adding to the events list on enable, and on disable, you're going to want to disable your actions and unregister your events. You can register by doing a plus equals and then allowing autocomplete to fill it in for you, or you can manually type in a method that is a void and has a parameter of input_action.callback_context. And that is the bare bone basics of using the input system for Unity. There is obviously a lot of additional complexity that goes into this system, but at the basic level, this is how you use it. If you found this video helpful, thumbs up would be appreciated. And if this was confusing or not really all that great, well, give me a thumbs down so I know to do better next time. Until the next video, take care.